All right, we'll kick off because there's not many, not much space left. So, wow, thank you all for coming. If you've got deja vu, I was here earlier, maybe about an hour and a bit ago. So it's nice to see a few familiar faces. Yeah, it's not like one of those recurring dreams that you have where, yeah, I'm going to wake up in a minute and I'm going to be somewhere else. No, I think that if you're here, hopefully you're here for the right thing. It's my other talk today, which is about how to keep your apps secret. A lot of you already know this, so I'll rush through this. But in case you weren't here earlier, my name is Ed. I'm the lead Android developer at ASOS. I'll make the same joke. It doesn't look like I work in fashion, but I work in fashion. ASOS are a retailer of clothes that ship all around the world. I'm also an Android GDE. I like to talk about mobile security a lot, as you can tell. I'm here again doing it for the second time today. I'm available on all good social media and Twitter, now called X. I managed to change the slide from earlier because I realized I messed that up. This is now my second talk in Lisbon, so I've finally got the first one over and done with. Now you're here for the good stuff. Thank you again for coming, and yeah, let's kick things off straight away. So the first statement, every app developer has secrets. Now, we all have secrets. There's no denying that. And I'm not talking about your browser history. I'm not talking about that stuff that you've hidden at the back of the shoebox. Like, no, I know, we all know about that. I'm talking about secrets in our apps. So what are secrets in our apps? For me, it's probably the spaghetti code I wrote about 3 years ago and hoped nobody would find, or maybe those to-do comments that I've left in the code and not looked at for a few years. But what this talk is actually going to be about instead is API keys and secure strings. Basically, anything that you wouldn't want somebody to have in their hands that could have, nefarious intent. If you go, for example, if you go on GitHub and do a very rudimentary search, you can find a lot of secrets out there. Some of them are more secret than others. I have, for the sake of people's privacy, obviously obfuscated them here, but we're not very good at managing secrets. So this talk, the whole purpose of this is to try and get a bit better and make sure that we're kind of following best practices there. So let's talk a bit quickly about kind of the harsh reality of kind of what we do. Unfortunately, secrets are a part of our job. We very, very commonly have to handle them in our apps. Cyber News did a survey in 2022, and they estimate that roughly 55% of apps have some form of hard-coded secrets. You can see the graph on the right-hand side there of kind of what that breakdown was. There was lots of different things there, whether it was Google storage buckets, Firebase URLs, Facebook app IDs, and then just other secrets. I like that they just got bored after 4 and was just like, yeah, everything else. So yeah, depending on kind of what what secrets you've got in the app, they pose very different levels of risk. We'll talk about that in a second. So, okay, fine, yeah, we know we store stuff in our apps, but what could possibly go wrong? Well, I'm glad you asked. So let's start off with Firebase. The vast majority of us probably are using Firebase or have used Firebase. In fact, more research by a company called Comparitech roughly estimates that 30% of Play Store apps utilize Firebase. I heard 30%, and I actually think that's wrong. I think it must be more than that. But they say 30%. In their analysis, around 5% of that 30% actually expose data. So through rules in the apps configured in Firebase configurations, they were actually able to extract data. Now, some of that data is on the right-hand side. It included personal information, included passwords, included password retry attempts, which is a crazy thing to store, but why not? Basically, if you misconfigure Firebase, you can end up exposing data. Integrating Firebase, they do force you now. It's very good. They do try and force you into following best practices. But unfortunately for us, reverse engineering is really, really easy, and to some extent can even be automated. So this is not to scare you, but if you haven't integrated Firebase correctly, this is something that could happen to you. We'll talk more about that later. Another good example here would be AWS. AWS being Amazon. Researchers, again, CloudSec, have said that roughly 0.5% of mobile apps expose AWS API keys. Now, that is problematic for a number of reasons, because AWS can expose a lot of different services. Again, things like storage buckets and databases, and there's been some really notable data breaches over the years. AWS keys can also allow attackers access to your infrastructure. So a couple of notable examples I've put on the screen here. Verizon, WWE, which is the wrestling, not the panda savers. Accenture, and yeah, many companies over the years have been breached by having AWS keys either stolen or exposed, or yeah, not necessarily through the application, but this is a risk that you run. And yeah, you can lead yourself into a lot of trouble. So more generally speaking, kind of what is at risk when we're kind of exposing secrets? I've kind of tried to highlight some high-level ideas here. The first one being stability. Stability, by accessing secrets like API keys, a malicious user could, in theory, perform a denial of service attack on a particular service that you might consume. So if you are, for example, have a rate-limited API that you're consuming in your app, and a user manages to grab your API key and wants to use it for their own purpose, or they just want to screw you over, they might be able to automate a script which might be able to then deny you might hit rate limits and therefore deny legitimate users of that service. Another example would be finances. I think this one's fairly obvious, but if you expose an API key that has paid services, a malicious user could use that API key to perform expensive actions and run up a cost in your own pocket. So yeah, that is a real danger. Reputation, of course, if users find out that you have not been following best security practices, not really going to want to use your app anymore. So reputational damage, can have a negative effect in multiple ways. Again, financially, if users decide to not use your product, or just generally, word of mouth can mean that you don't get as many downloads. Security, of course, I think this one's kind of a given, but if you've not followed security best practices, you may end up exposing more data, user data, user sort of information that you wouldn't want to expose. And ultimately, the most important one that you care about in the room today is your own job. Because if you mess this up, in theory, if your boss isn't very happy, who's going to get the blame? Is it going to be your boss, or is it going to be you? Unfortunately, probably you. So at this point, if this is you, if this is me, don't sweat. This talk will help. We'll go through it. We're going to discuss some top tips to kind of help us out. So the very first top tip is don't store secrets in your code base. So we're not talking about the app, we're talking about your code base. So when it comes to code bases, I've kind of found a few common issues. Now, I'm not going to do a show of hands because I don't want anyone exposing if they've got anything wrong necessarily in their setup, but hopefully maybe some of these apply to you, and we'll go through them. But first of all, if you have secrets hard-coded in your files, so in your Gradle files or in your Kotlin files, etc., that's no good. You don't want to be doing that. If your secrets are currently stored in version control, a lot of us use Git, a lot of us probably have apps that have been in a Git repository for many years. And that kind of leads on to the third point. Do you know if the Git history contains any secrets? Your app might be all right at the moment, but historically, if I was to get access to your Git repo, would I also get access to your secrets? And then also, I guess, do you actually have a process in your company or on your app to detect secrets? If I accidentally add something, who's going to notice? We'll walk through some examples now with some tools that will help. So the very first tool is hopefully something that you are probably already familiar with. This is a relatively modern tool, but this is the Secrets Gradle plugin for Android. What this is literally a Gradle plugin for Android, which allows you to take secrets out of your code and put them in a secrets property file. This secrets property file is a file that is local to your machine and not something that is checked into version control. Now, for kind of compatibility reasons, you can also supply a default properties file, so everything still compiles, but that should just have stub data in. You can use this secrets property file on your local machine to build, and you can also use, inject this as a proper secrets.property file into your CI, so your app builds with the correct secrets, and you're not exposing, therefore, the secrets in the code itself. So, you need to ensure that your secrets properties file is in git ignore, so please make sure that you aren't committing your secrets.property file, but the secrets.property file might look like something in the middle there where you have an API key and then your legitimate API key, and your local one would obviously have that key, but as a stub. So what that actually allows you to do, the plugin, what it does is it puts it in the build.config, and you're also able to access this via XML. So in this case, I think this is now the recommended way of working with the Google Maps API key. This is just some example code to show you kind of how you would do that in the real world. So As with everything, and if you've been to my talk earlier, I love talking about pros and cons. So pros and cons of this is it is very, very simple to integrate for most Android apps. If you are using Gradle, you can definitely use the Gradle plugin for Android for secrets. It also removes secrets from your code base or version control. Not your history, we'll talk about that in a second. It's an official solution, so it's a plugin that's actually made by Google, so you can be fairly certain that it will yeah, I was going to say last a long time, but it's Google, isn't it? So you never know. It is the recommended approach, though, so that is important, and it is also very CI friendly. So because it's CI friendly, it's something that you can integrate into your pipelines very, very quickly. The problem with this is kind of threefold. First of all, it bakes secrets into your app, so that's still a problem. So the secret has moved from your code base, but is still in your app, but again, we'll get to that. It requires you also to share the real secret files with all developers. So once you have your local file, you need to make sure that the real file is also given to every developer so they can compile the production app locally if that's something you need to do. And this doesn't offer any encryption or obfuscation. So to some extent, all this is doing is just moving secrets from one place to somewhere which is outside of your Git repo. Okay, we've ticked off one issue. That's the first issue, secrets hard-coded in files. Let's move on. Let's look at Git leaks. So this scenario, we want to kind of find out what secrets are in our code base. So we have a tool. There's a really good tool. I use Git leaks. There's quite a few different tools that do this. I find this one to be the best. There are other ones. Trufflehog, I think, is another one off the top of my head. And there's one that sounds very similar to Git leaks that I always forget. But Git leaks is a CLI-based tool which will search your code base for secrets. It has a list of kind of known, regular expressions, and it also kind of can handle very common secrets that we would find in Android apps, things like JWT tokens, AWS, Google Cloud tokens, etc. So this is a really easy tool that you can configure. You can run it locally on your repo. It's installable via most package control programs. And it's also available as a kind of GitHub action and a pre-commit hook. So you can kind of make sure that you're using it in the way that suits you best. With all of these tools, there is a QR code at the top, so do feel free to scan that. And slides are online as well, so do check that afterwards. With Git leaks, I mean, as always, there are pros and cons again. Git leaks is something that can integrate into any project. So Git leaks will run on Android apps, it will run on iOS apps, it will run on back-end apps, it will run on everything. So it's a really versatile tool. It searches your Git history for you, so it's going back over time and not just checking your latest commit, but also checking everything in the past. It's highly configurable. I don't have nearly enough time to go through all of the different parameters, but you can go and read the documentation. And like I said, it has many, many ways to fit into your workflow. Again, being CI friendly through things like GitHub Actions and commit hooks. It isn't mobile specific. So, because it is kind of this agnostic tool, you might be missing some kind of secrets that are unique to you or more unique to mobile use cases. But because of the configuration, it's also kind of a pro. You are able to kind of configure and add your own. Of course, yeah, that is something you'll manually have to do. There are occasionally false positives. We, in my code base, have a couple of times where we fake tokens and it manages to spot those. So there are occasions where it will flag stuff that you don't want it to flag. Again, there's ways kind of around that it allows, but it's good that it's finding the false positives, in my opinion. But it doesn't remove the secrets. That's, I think, the most important thing here is this tool is to tell you what is currently secret in your app as it stands right now. So what that actually means is that we've completed kind of two things off our checklist. We've got the secret hard-coded in files, and we've got now not knowing if there's any kind of things in the history. So at the moment, what we need to now do is kind of figure out, okay, well, we've got no secrets in the code, but we still have the secrets in the Git history. How do we get rid of those? There's multiple ways that you can rewrite history. We've kind of already gone through this, and hopefully, hopefully some of you are here for the keynote. Git has its own answer, which is git filter branch. You have seen that. There's a very handsome guy there who talked about it earlier. And there are a couple of community written tools as well that we will discuss. So as I said, git filter branch has kind of already been done. If you want to If you want to learn more about Git filter branch, which is one option, please watch Ben's talk. Have you got the photo, Ben? Yes, he has. Brilliant. Yeah, so please watch his talk. He does a great job of talking about it. He does a much better job than I do. But Ben did mention in his talk 2 other tools, and those 2 other tools I will go into detail now. So the first one being Git filter repo. Git filter repo is kind of GitHub's recommended approach for rewriting history and being able to remove things like secrets from your app. It's actually a Python script, and it's available, again, via many package managers. The way it works is you simply create a password.txt file. This password.txt file is essentially a list of the secret strings that you want to remove. So if you have API keys, you can, I think, just add a whole bunch of your API keys and set it to work. So there is a command there, git filter repo -- replace -text passwords.txt. And what that will do is go through your repo and rewrite the history, removing any kind of usage of that string. I recommend going to get some lunch because this process can take a bit of time, especially if you've got a large code base. There's a lot of history to rewrite. So yeah, make sure you go, enjoy your lunch, come back and be safe in the knowledge that you have removed some strings from your history. The other tool that's kind of used for this is something called BFG. BFG Repo Cleaner is actually an executable jar file. So this is slightly closer to some stuff that we would normally use. Again, it works in a very similar way. You, again, create a passwords.txt file. You make it have a list of all your secrets, and you run it. And in this time, you go and get some dinner because you've just had lunch. So you go and get some dinner. So if you fancy just skiving off for the day and telling your boss, oh, I'm doing something important, run this because it takes a little bit of time. It doesn't take that long, but depending on the size of your repo, there might be a lot of stuff to rewrite. Let's just visually show how this kind of works. So in this example on the left-hand side, hopefully this is big enough again for people at the back, but we have an example txt file. It says my secret. If we create a passwords.txt file with my secret in and run BFG, that will kick off the process of going back through history and checking for any cases where my secret was part of the text of a file. And once that's kind of run and we're all happy, you can see that it's replaced with this removed kind of placeholder. So what that means is if you go back to any point in time in your history, you should now no longer see my secret, but you should see removed. Now with this history rewriting tools, there are a lot of pros and cons. The first one being that they are highly performant when compared to the Git alternative. They've kind of been tailored for this use case, so they are very, very quick when compared against Git. Unfortunately, they're still not fast tools by any means, but they are doing quite a lot of heavy lifting, as you can, I'm sure you can understand. These tools also have other uses. They're not just used for secret removal. They can remove very large files. They can remove, any file you wish. They're very great tools for removing and rewriting history. Git filter repo is a little bit of an extension on BFG. They've kind of made some different design choices and different decisions. So I would recommend kind of looking at both. If this is something you need, have a look at both and see which one is tailored best for your use case. For example, BFG doesn't overwrite your current latest commit because it wants you to still be able to build. Whereas Git filter repo by default, I think, would remove the secret from everything, including the latest commit. I also really wanted to find out what BFG was referring to because there's obviously BFG, The Friendly Giant, which is a book. And I was wondering what it was named after. And it was named after, partially, the ultimate weapon in Doom, which I think is awesome. So a great name. So that's a tick as well. Obviously, when you're rewriting history, this is a very dangerous action to be doing. Here be dragons. There are a lot of risks with this. So you need to tread carefully and make sure that you're doing this in kind of with your team. This will likely, well, it almost certainly create breaking changes to your Git history. So if you're going back in time and you've removed a secret, bear in mind that you've just rewritten history and maybe your app won't build anymore. It also requires all clones of your code base to adopt changes. I know Ben talked about this, but obviously if you've made sweeping changes across your code base, these need to be applied to every developer in your team. So again, hop on a call, discuss it with your team, make sure that you're doing this together. And as I've said multiple times now, changes can take a little bit of time on larger code bases. Cool, great. So we have now ticked off 3 of the 4. And now I guess that kind of leaves the last one, which is the process to detect secrets in your code base. So for the first time live, welcome to Cooking with Ed. So our first recipe today will be for a secret-free code base. The first step is to run git leaks and then migrate any secrets to the Git secrets plugin. You can then use BFG or Git filter repo to clean up Git. You should then bake for 180 degrees for 20 minutes, sprinkle these tools into your CI and processes, and then serve your fresh code base to your hungry developers via a Git push force all. So yeah, my wife said to me, she said, "You don't cook, you're not going to be very convincing." And no, I'm rubbish at cooking, but that is a good recipe, trust me. Cool, so let's move on. That was tip number one for kind of a secret-free code base. Next up is how do we secure our secrets? So we've kind of cleaned up the secrets, but how, if we're baking them into the app, how do we secure them? So this has been me before, where I've woken up in the middle of the night and realized that maybe there's something in the app that shouldn't be there. Hopefully this isn't you as well. But the point is that it is very, very easy for malicious users to use a tool like JADX or other kind of decompiling tools to be able to look at your APKs, look at your binaries, and be able to pull out API keys that could, in theory, be abused. So let's talk now quickly about some kind of realistic use cases of when this might be a problem. Now, the first one that comes to mind, and we've already kind of touched upon, is Firebase and Google. One of the common questions I get asked, and I have people I see online asking, is what do we do with our Google services JSON file? The truth is to some extent, they are totally fine to commit and expose. However, big however, you must restrict the API keys. Now, I'll show you what that looks like in a second, but you can do that by visiting the Google Cloud and Firebase consoles and making sure you invoke principle of least privilege. Now, what is principle of least privilege? Principle of least privilege is the concept that the user should only have access to the functionality they actually need, and that, to make sure that you aren't giving additional scope in kind of what you're exposing through an API key. What's really cool about Firebase and Google is that they allow you to kind of restrict the keys. Now, this is what you need to be doing. This is what you need to go home and check you are doing. You need to make sure that your API keys for Google and for Firebase are restricted. Now, you do that twofold. First of all is via package, so it does it via your package and the SHA fingerprint of your binary. So if you have a production binary, you want the SHA there, and if you're using it in debug, you also want the key, the fingerprint there as well. And then you also need to restrict which APIs you use. Now, these APIs should only be ideally the APIs that your app utilizes. Now, if, for example, in future you want to add one, then yes, it's fine. You can definitely go and add one here. But the vast majority of users don't click that button. Most people click don't restrict key. And that allows any user to, if you haven't done the first step, to use your API key to do whatever they want. So if there's one thing you need to take away today, it's that you need to check that. The vast majority of you will be fine, but please check that, preferably after the talk. After the talk, Ben. Stop it. Cool, okay, but this is probably you now. Okay, great. What about every other secret? Well, there are other tools available on the market that can help us kind of encrypt data and secrets within our app. One such one is DexGuard, from my friends at GuardSquare. Give us a wave. There she is. we have someone in the room, perfect. DexGuard is something that you might be using. It is a paid enterprise solution, so it's not necessarily something that everybody has to hand. But what DexGuard does have is the ability to encrypt classes and strings within your app. The way that this actually does this is magic. Of course, it's an industry secret, so they're not going to tell me how they do it. But all you really need to understand is that the setup for this is very, very straightforward. It works just the same as kind of ProGuard in the sense of creating a config file and adding kind of your the relevant encrypt strings and encrypt classes commands there. What's really cool about DexGuard is that this is only like a sprinkle of what it does. It does so many different cool things, but it also utilizes real runtime application security protection, RASP, to detect attacks on your running app. So if somebody is trying to use, for example, Frida if you've ever heard of Frida, to kind of dynamically attack your app, your running app, you should also be able to then protect against that through using DexGuard. So it not only encrypts your secrets, it also stops your users from trying to get them at runtime. DexGuard has, of course, pros and cons. The first one is obfuscating secrets in your app. So if you decompile the app, it's going to be a lot harder to find the secrets. It makes it way more difficult to reverse engineer. So it's a really worthwhile product in that sense. It's used in production by many, many large applications. So, it must be doing something right. So yeah, definitely a lot of big names are using this. It provides way more features on top of that. This is, again, just like a dip in the ocean of what it can do. GuardSquare support is great. I love working with them. They're great people. So yeah, thank you for them. It is a paid tool though. So this isn't going to be available for everyone. That is obviously a barrier of entry, but if you work at a large company and have some budget, it might be worth investigating. Using it just for this is probably overkill. Like I said, this is only one of the many features it has. And there are other competitors as well, so make sure you do your own research. I'm very good friends with GuardSquare, but there are other companies out there that perform similar things. So do your own research. This might be a good tool for you if you're working at that kind of enterprise level. However, if you're cheap and you want to do something for free, there are other solutions out there. I've kind of highlighted free here. I'm not going to go into all free because we don't have time, but there are 3 different kind of solutions here as well that you can kind of use to encrypt secrets into your app. The first one, Hidden Secrets Gradle plugin, is a Gradle plugin that utilizes the native development kit NDK to kind of hide secrets in the NDK to make it more difficult to reverse engineer. Then there is ByteMask, which is also a Gradle plugin, but this uses a code generation approach. So this isn't actually using the NDK. This is kind of using a code generation approach where you use a Gradle task to create a secret and then bake it into the app. And then you've got Secret, which is actually, I think, a fork of the first one. I might be wrong, but I think it's heavily inspired by the first, and it is a Kotlin multi-platform plugin, so it might be slightly more relevant if that's kind of the space you're working in. Let's quickly look and see what this actually looks like. So I've used the first one here, Hidden Secrets Gradle plugin, as an example. Hopefully you can see this again, but what this creates when you input the secret is an obfuscated secret, which is essentially a byte array. And then essentially you use this secrets file that's generated to then get the key by passing in the package name, which is then used to kind of decrypt it. So it's not perfect. It's certainly reverse engineerable, but it is a lot harder to do so, and it is an increased level of security to some extent. It makes it more difficult for attackers to kind of see what's going on. Pros and cons, again, it obscures the secrets in the app, so they're not in plain text anymore. They're slightly more difficult to access. Setup is really, really straightforward. You can do it in a matter of seconds. It is more difficult to reverse engineer, and this is kind of a good approach maybe for small projects, hobbyists, indie apps. If you're like an indie developer and you want a level of security and don't have a budget for an enterprise solution, this is a kind of affordable and accessible tool. Again, like I said, still very possible to reverse engineer. It can add a dependency on the NDK to your project, which is never nice. Unfortunately, if you're not using the NDK, it adds it as a dependency, can slow things down a bit. And it's probably not good enough for large-scale applications. So I would not recommend using this at work. But if you work in a small app or doing something independent, this might be a good approach. So without further ado, it's cooking with Ed time again. So this is a recipe for better hard-baked secrets. The first is you should always restrict your API keys usage if you can. If you use an API key or something that allows you to restrict scope, allows you to follow kind of the principle that we discussed earlier, this is what you should be doing. So make sure you do that. If those tools that you saw beforehand are kind of something you're interested in, then definitely look into those. One of the common myths that we need to bust as well is that using the NDK won't solve all of your problems. It is, it's something that is utilized but isn't a silver bullet. And remember, I think that hard baking secrets into your app is always a risk. So yeah, don't get burned. So that leads me to my third and final tip, which is get rid of your secrets. And I can know what you're thinking. Well, duh. How? So this is what we'll discuss now is kind of the ideal perfect solution. It's not something that you're going to be able to go home and implement necessarily in day one, but it is kind of how the larger scale applications do it and something maybe you can take home and think about. The high level example is this. You have your app, you have what is called a proxy server, and you have the API you're trying to reach. Now, previously what you would be doing is presumably your app would be directly reaching out to the API, and the API would be returning functionality back to you. In this case, what we've introduced essentially is middleware. It's a proxy server that you own that you can then hit and get information from the third-party API yourself. So if we follow the kind of flow of data here, you would have your own presumably API, you would call your proxy server. The proxy server would call the API that you wish to fetch. The response would then be passed back and then sent back via the proxy to your app. So it takes a little bit longer, but hopefully what is fairly obvious is that now your secrets are in the proxy server. Your secrets aren't no longer in your app because your proxy server is the only thing that's communicating directly with the API. So this is kind of how the ideal solution should work, but it's not perfect. So let's think quickly. How could this be abused? Well, for a start, non-legit calls to the service. We could just use a script or another app. We could just call our service and get all the information we wanted from the API. We could have a denial of service attack. We could just make a load of calls to the proxy server and crash it. Or we could, even if in a more sophisticated attack, complete a man-in-the-middle style attack where somehow we're able to kind of listen between the proxy server and the APIs to be able to kind of capture the API keys, etc. So there's a few things we can do to try and fix some of these. The first one's being secure the API calls. So very first thing first is that the app should be communicating over HTTP. HTTPS, hopefully everybody's doing this. Hopefully nobody's using HTTP at the moment, but it's still worth mentioning. We then also need to make sure that we're authenticating calls to the proxy server. So we are making sure that we are getting legitimate calls from legitimate users who we trust. And to do that, you can use tokens. Many of you have probably got some sort of token flow in your app already. Ideally, you want to be kind of using revocable short-lived tokens, maybe JWT tokens, and making sure that that kind of authentication flow is implemented so your proxy server is only being accessed by people that you want to access it. Again, you could also rate limit it. So one of the problems we discussed was maybe getting a script to hit your proxy server many, many times. You can implement rate limiting. There's plenty of tools out there to do it. And again, remember principle of least privilege. We want to make sure that we are thinking about only exposing the data to users that they actually are able to access and not exposing more functionality than we need. Another solution to try and fix the kind of flow that we've discussed is through device attestation. That is essentially the official verification of something as true or authentic. In this case, making sure that the calls are coming from legitimate Android devices. There was a really, really good talk about this at IO24. I've put a link to that down below. Please do watch the video. Very, very good. But essentially what we can use to do this is something called the Play Integrity API. Now, hopefully some of you have heard of that. Hopefully some of you are using that. But the Play Integrity API is a tool that could be implemented in your app prior to calling your proxy server to make sure that the Google would say that your app is safe and secure and a legitimate device. What that would then do is obviously block any malicious requests and make sure that you are authenticating correctly. So what that kind of leaves us with is a graph that looks a little bit more like this, where your app would first call the Play Integrity API, you would get a response back, then you would call your proxy server, which would then call the Play Integrity API, that would then go back, and then you would call your identity server to make sure that you are a legit user, and then that would call the proxy server. You get the point. It is a lot more complex, and in the real world, this is actually how it's done. And I'm not a back-end engineer. I'm certainly not a solution architect. You can tell that for sure. But it's this is a problem, and this is kind of the way that it is solved in the real world. So yeah, on the theme of cooking, I want to kind of introduce this Swiss cheese model. The whole idea with the Swiss cheese model, and hopefully everybody knows what Swiss cheese is. In case you don't, it's that. It's the cheese with the holes in. The idea is that you have many layers of defense here represented by cheese. And there are flaws with everything, right? There's no silver bullet, there's no perfect solution. But the more cheese you have lined up, the threats that come to your app, the more defenses you have, the less likely something is going to find right its way through, representing kind of access to your app or access to your data. By having more cheese, more security defenses, you will inevitably have a safer app. So hopefully that makes sense. If it doesn't make sense, just remember, more cheese, less problems. I think that applies always, right? Again, a key takeaway from this talk. So let's quickly talk about the API proxy service. The pros and cons of that. Well, the first pro of that is it finally has removed all the secrets from your app. It's also highly scalable. Be it kind of back-end technology means that this is something that can scale with your number of users, whereas other solutions may struggle. The back-end is also more traditionally harder to exploit. So yeah, it's slightly more safe as kind of a security surface. And you can also do kind of cool things that you couldn't easily do in your app before, things like rotating keys without disruption. If you had an API key in your app and you need to rotate it, well, crap, you've got to now release a new version of your app and make sure that all of your users are on that. So yeah, this is a much safer solution for that. You can also then have more increased logging and reporting because you now have a full log of who is accessing your API and when. And you also now control the API between your front end and your back end. So if there's data that you want to omit, if there's data you want to mutate, if there's data you want to kind of handle in any which way, this is a great solution because you now have control over the APIs between your app and the proxy server. The cons, hopefully fairly obvious, but this requires way more effort, like way more effort. It does also increase latency. There is a lot, because there's a lot of moving parts, it's not as quick. There is issues and it's not as fast, but it is safer. There is also now a single point of failure. If your proxy server goes down, well, you have no access to any of your APIs or third-party APIs. So yeah, it's slightly problematic in that sense. Again, this is very big tech friendly. So if you have a lot of back-end engineers, a lot of security people at your company, this is great because you're going to take this to them and they're going to say, yeah, we can do that. Whereas if you are one or two people in a startup, this is going to be very difficult to pull off. And in reality, like I said, the graph before, I'm not a solutions architect, but it's way more complex than the example I gave. This is the final time, I promise. This is the last time. The last recipe of the day. So this is the recipe for a near perfect application. First of all, remove all the secrets from your app. You can then provide their functionality via a proxy server that you control. You should then obviously rate limit that to your liking to make sure that nobody's abusing it and ensure that only real devices and known users can access that service. You should also apply the Swiss cheese model very generously because who doesn't want more cheese? So in summary, this is your key plan to have safer secrets. The first, erase historic secrets from your repo. Always restrict your API keys if you can. Obfuscate to add an extra layer of security if you wish. Consider device attestation to make sure that only legit users are accessing your APIs. Be very aware of your baked-in secrets, and if you can, proxy calls and remove in-app secrets completely. Remarkably, I've done well for time. That was pretty much dead on. Thank you very much for having me. All of my talks are available online. There was the one earlier. Hopefully the slides and everything should be available on there already. If they're not, check my Twitter, it's on there. And that's it. Bon appetit. Thank you.